when they give us these problems where we're using I to a kind of large power, they don't expect you to actually multiply that out 51 times. We're trying to see, is there any kind of pattern we can use to our advantage? Well, first, if we think about like the definition here, I is just square root of -1. So like I to the first would just be I. And then I squared, well, if I is the square root of -1, if I square both sides, notice how that cancels the square root. So I squared is the same as -1. That will come in handy in the future. Anytime you have an I squared in a problem, you can just replace it with -1. So I squared actually isn't an imaginary number. It is I times I, which cancels to -1, or cancels the square root. All right, so I to the third. If we multiplied both sides by another I, right, it would be I to the third, and this would be -1 times I, so negative I. And then if I multiplied again, I would have I to the fourth, and so I'd have negative I squared. But then remember, I squared is -1, so this would really look like -1, which cancels and just gives me 1. And then if I multiply both sides by I again, I have I to the fifth equals 1 times I, so just I. If I multiply by both sides by I again, I have I to the sixth equals I times I is I squared, which is -1. Notice it seems to be repeating this pattern every 4. I, -1, negative I, 1. I, -1, negative I, and 1 again. So we can use this to our advantage and think, okay, well, every time I get, say, I to the fourth, or I to the eighth, or I to the 12th, something that's divisible by 4 for my exponent, I know that all cancels and just gives me 1. So if I can think of I to the 51st being some number that 4 goes into, so what's the closest number to 51 that 4 goes into? Off the top of my head, I'm thinking possibly 48. So I could think of this as I to the 48th with 3 left over. Or it's up to you as a preference thing if you remember that 3 of them gives you negative I. If you don't, you can go even further and split up the 3 that are left over as I squared and I. So you can get away with even knowing just the first 2 in the pattern. So I to the 48th, since it's to the 4th power, that'd be like 12 copies of I to the 4th. I know that's just 1 times 1 times 1 times 1, so anytime you get an exponent where 4 goes into it evenly, it follows this pattern, you just get 1. And then I squared is the same as -1, and I to the first is just I, so the whole thing I just end up with negative I. You could also kind of just follow the pattern and say, well, if I know that 48 is this one, then 49, 50, 51 is 3 away, so it would be this one. So either way, but you're just exploiting the fact that you know that this pattern, I, -1, negative I, 1, repeats every 4.